One of the things I find very interesting with IPv6 is that it likes to communicate. I mean, it really, really enjoys to talk. For example, when we configure IPv6 on interfaces, you'll remember from our last video that we not only got the IPv6 address of 2001 : etc. on R1's FA0/1 interface, we also had a second IP address that shows up. The focus of this short video is to let you know what exactly is that extra free IPv6 address that's configured as we investigate and learn about the link local IPv6 address. To pick up where we left off, we had configured R1's FA0/1 interface with an IPv6 address. And just as a refresher, what I'm going to do is I'm going to default the interface FA01 that'll wipe everything out that we've configured. And that way I want to walk through one more time of putting on an IPv6 address. I'm going to put on an IPv6 address. Let's verify first of all nothing's there. No IPv6 anywhere. I'm going to put an IPv6 address on this interface of 2001:db8:21:111. And this time I'm going to use just a 1 for my host ID. So I've got 64 bits of host ID. They are 0001 and they're right here. And I want to show you one other really cool trick that we can do. And that is we don't have to put in consecutive zeros. So an IPv6 address is 128 bits in length. This is the network address right here, and this is the host address. We already know that this group represents 16 bits, and this group is 16 bits, and this is 16 bits. But if we wanted to, we could actually shortcut having to type those in by simply putting 2 colons together. Take a look at the output here. This is the IPv6 address we put in, and this is the IPv6 address that's shown by the router. You'll notice that the 2 colons right here, side by side, represent there's some quantity of groups between those 2 colons that are all zeros. How does it figure out how many? Well, here's what the router does. It says, well, it should be 8 groups long. There's 1 group, there's 2, there's 3, there's 4, there's 5. There must be 3 groups in between those colons, and it automatically assumes, and that's how it represents those 48 bits. 16 times 3 is 48. So that double colon is how we could represent when we put in an IPv6 address if we have multiple series of zeros. You can only do that trick once per IPv6 address. For example, if I had 2 zeros here and 2 sets of zeros over here, I couldn't use colon here and colon here, because then the router wouldn't know, okay, is there 1 on one side and 3 on the other? So you can only use the colon back-to-back trick exactly one time. So let me go ahead and put in an IPv6 address as I really would on the network, and we'll take a look at the difference. So I'm going to default that interface again, and we'll simply wipe it out, and we'll go back into interface configuration mode for FA0/1. That's this interface right here. And I'll just do it the way we would do it in production. 2001:db8:21:111:1. It knows, it can figure out exactly how many sets of zeros are between those 2 colons because it knows there should be a total of 8 groups. So we get the same result here in either case, whether we put in the zeros or we put the colon back to back. So what have we learned? We learned that we don't have to put leading zeros within the groups. And if we have a whole bunch of groups of zeros, we can use a colon to make it easier and more efficient to look at and more efficient to type in. So the next thing I'd like to tackle is what is going on with this thing right here. This, my friends, is a link local address. Now, many of you might think, wait a second, I've got 2 IPv6 addresses on this interface. Why do I need 2? That's the way they wrote it. With IP version 4, we have 1 IP address per customer. That's all we need. But in IPv6, be prepared for 2 IPv6 layer 3 IP addresses. One is going to be reachable and routable across the internet. For example, this globally reachable IP address here that we configured. And this other one is going to be a link local address. If it starts with FE80, that's your key to saying that is a link local address, and it's automatically configured by default. It's only good, by the way, on that local segment. So if R1 wanted to communicate with other devices on this network segment, Every one of these devices would have an IPv6 address, a link local address that starts with FE80. And if we knew what the host ID was of those other devices, we could use it to communicate. I think the best example here would be to take maybe R1 and R2, which have not been configured yet, and simply enable IPv6 on the interfaces, not configure an IPv6 address, and watch and see how the link local address is automatically configured. So let's go ahead and start with R1. So we'll go to this interface right here on R1. And on R1, we'll simply, I'm already in configuration mode, so I'm already there. So in configuration mode, I already did a no shut on all these interfaces. So all the interfaces are already in an up state. And I'm going to simply go in and I'm going to enable IPv6 on those interfaces. So we'll go to interface FA00 right here, and I'm going to give a description. So we'll make sure we're talking about the right interface, which is important. And then we're going to do a do show IPv6 interface brief, just to verify that we have no IPv6 addresses whatsoever on FA00. And you'll notice that we don't at the moment. So now, when we configure an IPv6 address, it automatically enables IPv6 on the interface. And that's a default. However, if we just enable IPv6 and not assign an IPv6 address, it will tell that interface, hey, guess what? You're enabled for IPv6. It will automatically create for itself a link local address that starts with FE80. So now let's take a look. IPv6 is enabled on the interface. One simple command. And now we've got this beautiful link local address. And again, the giveaway is the FE80. It's a reserved address range that link local addresses use by default. So great. What is it good for? Well, this link local address right here is going to be only valid on this segment of our network. So R1 could talk to any other devices on this layer 2 broadcast domain right here to other devices to their link local addresses. So let's bring up R2 and let's go ahead and give R2 a link local address as well. So we'll make a road trip over to R2. So over on R2, we'll work with this interface right here, FA0/0. So we'll go into configuration mode. And we're also going to put a description there. This is the interface that's connected to R1, making sure we're on the right device and the right interface. And we'll do a do show IPv6 interface brief as well, just to make sure there's no IPv6 addresses whatsoever. And then we'll configure, well, actually we won't configure an IPv6 address, we'll just enable IPv6 on this interface. When we do that, it's going to automatically create a link local address beginning with FE80, and it can use that IPv6 address to communicate with any other device on this specific layer 2 broadcast domain. So let's take a look at the IPv6 address here. And here it is. So we have this IPv6 address that we've been assigned. We'll take a look at the magic of how it configured that. And basically what it is this. This link local address is 128 bits long. That's what IPv6 is. And you'll notice we have one group, two groups, three groups, four groups, which is 64 bits from here to here. And that's the host ID. R2 is using this host ID for itself on the FE80 colon and a whole bunch of zeros up to 64 bits for the network space. So the network is FE80 and a whole bunch of zeros all the way up to 64 bits. And then the host ID is this guy right here. So what could we do with this? Well, let me give you an example of what we could do with this. Let's take a look at that IPv6 address, this guy right here. And we should be able to ping that IPv6 address from R1. So let's make a road trip and let's go see R1 for a moment. And on R1, let's go ahead and ping that link local IPv6 address of R2. Now, the cool thing is this, it's going to have to say, the router's going to say, which interface do you want to source this from? Because I have two link local addresses, one up here and one up here. So I tell it I'm going to source it from FA0/0, and then it pings that IPv6 link local address of R2 that I pinged, and we have good connectivity. Now recall that the goal of the link local address is for connectivity only inside of this network. For example, if I wanted to talk to this PC up here, this printer, or host D, or host B, or host A, I wouldn't be able to use the link local address of R2 because R2's link local address is only good on this network segment right here. And it'll become more and more important as we discuss neighbor discovery and the communications that go on between two IPv6 neighbors that are on the same network. Now, can we talk? Let's take a look at this host ID that it generated for itself on this interface right here. This is C80111FF-FED48. And we know that's 64 bits, and we know that the leading zeros in each of the groups has been omitted for making it easier to read. Now, I want to show you how in the world it came up with that address. If we do a show interface for FA0/0, that's this guy right here on R1, and I'm going to say, please include only lines that have the word BIA, which is short for burned in address. Here's the MAC address that R1 has assigned to it, the hard-coded address from the factory for its FA00. It's CA0111D40008. Great. Now we know that layer 2 addresses in Ethernet are 48 bits. So here is the 48 bits right here. Now check this out. The beautiful thing is we know how to convert between hexadecimal, which is how MAC addresses are represented, and binary. We know that each character turns into 4 bits, so great. Here's the CA0111D4400008, just like it is right here. Now here's the magic. What we're going to do, well, not us, but what the computer does, the router does, it says, I'm going to take my MAC address off of this interface, and I need a unique 64-bit host ID for my link local address that starts with FE80, and what I'll do is I'll take my MAC address and I'll use that. But the reality is a MAC address is only 48 bits. We need to have a 64 host ID. So we're short. How many bits is that? Well, we're short 16 bits. So here's what the computer does with something called an EUI64 host ID. It takes the MAC address and it injects FFFE in the middle. So we take our 48-bit MAC address, we cut it down the middle, and that middle would be right here. We inject FFFE, so here's the FFFE in blue, they're color-coded, and now we have 64 bits, and we'll use that for our host ID. The other thing that happens is we have this universal or local bit inside of our MAC address, and what we're going to do is we're going to invert it. So we're going to invert it. If it was a 1, it inverts it to a 0. If it was a 0, it inverts it to a 1. And there's a whole story behind that, but it really doesn't matter too much for this discussion. I just want to make sure you're clear on how this router created its own host ID. So it took its MAC address off that interface, it flipped the 7th bit, it injected 16 more bits of FFFE, and that's its new link local host ID. It's going to end up looking like FE80, : which represents a bunch of zeros. So we have 1, 2, 3, 4, 5 groups. That represents 3 groups of zeros, which we know is 48 bits. And that's a full 128-bit IPv6 address. Half of it, the first half, is the network for the link local, and the back half from the C8 on is the host ID for that link local address. And if we look at it right here, that's exactly what this is. So that's the magic of how it got that address. Now, just as a demonstration, well, you may want to pause this and just look at this for a few minutes and get comfortable with it. But if you want to simplify your life, here's one way of doing it. Because we know the link local address pulls from the MAC address, we could hard code the MAC address and effectively change the end result of the host ID. So check this out. We do config t interface FA0/0, and let's specify the MAC address of 0000 and 1111. And you gotta love this too. It's like, okay, that's a MAC address, and it's represented with periods, but that's the way you represent MAC addresses, with the MAC address command. So we'll press enter, and now that we have that MAC address on that interface, if we do this again, show IPv6 interface brief, check this out. Look at our link local address. The host ID, it took our MAC address of 0000111111, it injected FFFE in the middle, right here, highlighted. It also flipped the 7th bit. So the first 4 bits was a 0, and that's not shown here because it doesn't need leading zeros. And the third bit in from the bits that were in that second character were all zeros. It flipped that bit, which was a 0, to a 1, and that's in the 2 position, so that's why it turns to a 2. So that's a link local address, and I'd like to give you one other tip. So here's the trick to hard coding your link local addresses if you want to. In configuration mode, we'll go to interface FA0/0. We'll say IPv6 address, and check this out. Link local addresses always start with FE80. And if you don't want it to use this EUI64 game, which is all about creating a unique host ID, we can hard code it. We can say, I want my host ID to be 1. Now, you and I both know that this is 16 bits, and that's 16 bits, and that's 2 groups that are shown, which means the router is going to figure out that there's 6 groups of zeros that are not shown here in the middle, and it's okay with that. If we want to assign this as a link local address, we need to use the keyword link local. So I don't need a mask because link local addresses are assumed to be 64 bits. I press enter, and now if I do a show IPv6 interface brief, check this out. Now it has hard coded on my FA00, my link local address of FE80::1. And that is my link local address. Still, it's only good for this segment right here, but it's not some wacky EUI64. Now, if I have 1,000 hosts out there on the network, I don't care, really, what they use for their host IDs. They can go ahead and use the EUI64 game. But on my routers, I very well may want to keep track of which link local addresses are in use, and so I can hard code them if I desire. One last thing I'd like to tease you with before I go to the next video is that how in the world does R1, when we put in this IPv6 address or when it does a link local address and makes up its own host ID, how does it know that somebody else on that network segment doesn't already have that same host ID in use? Because you can't use, with the exception of Anycast, but for unicast traffic, we can't have the same exact IPv6 address on 2 different devices in the same broadcast domain. So how does it know? And the answer is it uses something called duplicate address detection, or good old DAD. In the next video, I'm going to walk you through exactly how behind the scenes duplicate address detection is verifying that there isn't another IPv6 address in use like this one on that broadcast domain. I'm also going to walk you through what the router would use before it actually takes and uses that IPv6 address to communicate and discover whether or not that address is already in use. Thanks, everybody. I'll see you in the next video.